Today, Suvi and I, we are going to talk about why organizations are actually better without passwords and keys. Okay, so Suvi, why do we really dislike passwords?
Why? Well, one thing is that they are often permanent credentials, and they are credentials that go across the network, sometimes even unprotected, but even when they're not unprotected, when they're encrypted through secure shell protocol or TLS or something, it is still something that goes over the network and it grants you access to a system with something that can be potentially brute forced. So you don't really need anything else except that particular password. And then one major problem with passwords is also the fact how we have in this world trained our users about using the password. So in the beginning, we told them that, your password needs to be at least 6 characters long, and then it became 8 and so forth. And we tried to add, and then we told them that now you have to put some complexity in
Special
it.
characters and your mother's maiden name.
Exactly, like all that sort of stuff. And then we trained all the people to understand passwords as something that when they see that it looks a bit like random stuff, that's a good password. And usually people use really, really crappy passwords because what looks random to human is easy peasy for computers. So it doesn't matter how many fancy special characters and this and that you have in your password if it's short. So a good password requires I would say probably 25 characters at this point that you want to use, but it's not good password if you cannot remember it.
Yeah.
And it's really horrible password if you have to change it all the time. So I worked in my past life before I came to SSH in place where we were assigned, I think it was maybe 13 character passwords, and it rotated every month. So what happens when you do that? You're not, as a user, you cannot choose your password. You're giving a random password and you rotate it once a month. Can you guess what happens? Yeah, you can guess pretty much. It's a yellow sticky note that's stuck on your monitor or under the keyboard or something. So by the time you learn it, you're already, it's time to change the password.
Yeah,
so the password rotation is crap. So that's one of the reasons why they're so bad. Fundamentally, even in the most ideal situation, if we could re-educate everybody to use really good 25 character random passphrase type of passwords, it still leaves that one little thing, which is really the fundamental problem. It's the brute force attack. So you are still able to use a password to logging into the systems. It's sent over the net. So it doesn't really solve that problem at all, because for that, we have then, for instance, in the secure shell protocol, we have figured out a way of using asymmetric keys. So that's a major difference. You never send any of that sensitive data across the net. That is a step to the right direction, getting rid of the passwords.
But it has its problem.
Then it still is a permanent credential that you still have the problem of, okay, let's rotate this. And then it requires you to do something. And it's kind of easy if you have a small environment. But then when we talk about millions of keys and stuff, it actually becomes a burden that by the time you're kind of done with the rotation, you have to start again because you don't have enough time. Even if you use our universal key manager that's capable to handle these sort of millions of keys in the environments, it's still not very efficient way of doing it. So then what's the next step and how this can be solved? I guess that's when you were hired for the company to figure this.
I think I was hired a bit before than that, but so we started to figure out how to kind of do the SSH authentication without keys, because even though it's a nice kind of authentication method, or the public key authentication in SSH is a nice authentication method, the problem with that is that the private keys are files, and those files can easily travel, even perhaps more easily than passwords. So for that reason, we introduced a privileged access management solution with ephemeral certificates as the authentication method. So there are no permanent left behind files or keys used for the authentication. Everything is done just in time and as needed and can be controlled. But it's still, it feels a bit funny that it's 2023 and still over 80% of cyber attacks happen using stolen credentials, mainly passwords. And as long as there's a password, the hackers can get in using kind of social engineering. And even if you have SMS-based MFAs enabled or TOTPs, those SMS-based TOTPs can be also forged. So there are different methods to bypassing those. So basically, the only or the best way to do authentication is using ephemeral certificates.
So the security should never be based on some sort of obscurity setup where the user could accidentally or deliberately circumvent it. Like we take that away.
Well, that's how it should work. I mean, access should be always tied to the HR processes. If a person joins the company and gets assigned to certain groups in the identity provider. So for example, if they work in IT, they get added to IT group, or HR, they get added to HR group. Then that group membership should be kind of the key whether or not that user is able to access certain applications, or if that user is able to access network devices, if he's in the IT group and so forth. So it should be always be kind of based on HR processes. And it also, when that happens, then joiners, movers, and leavers are basically handled automatically. There are no left behind credentials. If somebody leaves the company, they are removed from the kind of IDP, or they are marked as disabled in the IDP, then all the access actually disappears at once. And even ongoing connections get terminated. So that's how it should work.
So in the very beginning, I think the idea was that we would just handle this sort of like connections with the authentication and authorization. It would be the role-based access control, but pretty soon it was clear that that wasn't all what the customers wanted. So they actually wanted to be able to see what these privileged users are doing in the environment. So the other part of it is that if you don't have visibility into this system, you're flying blind. So there's that.
Yeah, when you talk about zero trust isn't just authentication, and it isn't just having kind of a CM or some solution in place to monitor what happens on the kind of in the infrastructure. It's kind of a suite of solutions or products. And authentication is one part. Then granular access through role-based access control, that's the second part. Then auditing is one part as well, or kind of perhaps the last part. But then an important factor is that you gain visibility on what the users do on the target system. So audit trails, audit events, restricted commands, shells, and it's really important that you have kind of a full stack of features or products in place, so you can kind of control the whole life cycle of the connection or the user's actions in the infrastructure.
And what I like about PrivX is that we store the protocol trails as the protocol packages itself. So it's not like taking a whole lot of space when they would be just like videos or something like that. And also the fact that it's a future-proof thing. Like we don't know what will be the next stuff that we will invent. So it will be nice to be able to take the audit trails from years back if needed.
Yeah, I mean, as we know, zero trust isn't a single solution. It's formed of components. And of course, we already believe at SSH that we have a pretty good suite of products which enable zero trust use cases for our customers, so kind of being zero trust compliant. How do you see, what are the next important components in the zero trust journey?
Yeah, very difficult question because trying to predict the future. But well, we do know that we have to go to the quantum safe world, and we have to get there before the cryptographically relevant quantum computers get to the quantum era. So that is something that how secure is your current systems, if you think it from the point of view that in a few years' time, if everything that you have been so like building all these access controls and authentication to secure the data payload that goes in the networks, if that's all essentially plain text in 10 years' time, because that's when most likely we will get to see these connections breaking. So we have to start moving toward that now to put in those post-quantum cryptography algorithms in place. And we have already done that with PRIVX, for instance, in certain use cases. And that will ramp up even more so later this year, and especially 2024 is kind of the year when many vendors are, by certain regulation and stuff, forced to provide those solutions, and it will kind of x-ray the whole thing. It's not just these communication protocols that we're usually dealing with.
I think that it's important to kind of recognize at this point that what we do with post-quantum cryptography, it's actually really pragmatic, and it's basically cryptography you can do on classical computers, which you can basically implement nowadays just by changing the algorithms you use when you do connections. So it doesn't require any new hardware, it doesn't require new kind of connection mechanisms, and it basically just works. So it's really pragmatic way to be quantum safe in the future.
Yeah, and in our view, when we've had these discussions internally, is that we see it as the only viable route to get the quantum safe in time, because in many ways we're already late.
Yeah, and we also want to be open in a sense that we don't want to create a closed garden so that only using our solutions you can be quantum safe. We want our products to interoperate in the wider ecosystem and to be able to kind of to enable our customers to be quantum safe even when operating against open source components or other vendors' products. So that's I think that is the kind of quantum safe future that we are driving.
It's fine, like our future looks a lot like our beginning. So SSH went in with this fancy slogan that, you know, we're making the internet secure, and we're kind of doing that. We're making it now quantum secure. Hey, thank you, Miikka, for this discussion. I guess we have to get some hot tea and start planning the next steps.
All right, thank you. It was really interesting.